You see it every single day. That little padlock right there in your browser's address bar. We all know it's supposed to mean safe, but have you ever stopped to wonder what it's actually doing? What's really happening in that split second to earn that lock?
I mean, what is that symbol really protecting you from? And how does it even work? Well, today, we're going to peel back the layers on one of the most fundamental and honestly one of the coolest security features of the entire modern internet.
To really appreciate the solution, that's HTTPS, we first have to understand the problem it was built to solve. And that story starts with the original language of the web, plain old HTTP.
So, with plain HTTP, all the data you send is in what's called clear text. The best way to think about it is like sending a postcard. Anyone who handles it along the way, from your Wi-Fi router to all the servers across the globe, can just read the whole thing. Nothing is hidden at all. And this right here is the fundamental difference. If HTTP is that open postcard for everyone to see, HTTPS is like a sealed, armored briefcase. That little S literally stands for secure, and all of that security comes from one powerful concept: encryption. And believe me, what's at stake is a pretty big deal. We're talking about things like your passwords, your private emails, your credit card numbers, all of it completely exposed on an old HTTP connection. Anyone watching the network, maybe on public Wi-Fi or through a compromised server, could potentially see everything. So how do we lock down that connection? The answer is HTTPS, which stands for Hypertext Transfer Protocol Secure. And it's all powered by a brilliant piece of technology called Transport Layer Security, or just TLS for short.
You can think of TLS as the engine that makes all this security happen. Its job is to create a totally private, encrypted channel between you and the website you're visiting. It makes sure that no one in the middle can listen in or, maybe even worse, mess with your data. But how does this secure channel even get created? I mean, it happens in milliseconds. Well, it all kicks off with this very carefully choreographed digital introduction that we call the TLS handshake.
The best way to think about this handshake is like a very formal, very fast first meeting. Before any of your actual information gets shared, your browser and the server, they need to introduce themselves, prove they are who they say they are, and then agree on a secret language that only they will understand. And it all happens in a few lightning-fast steps.
So it all starts when your browser says hello to the server. It's basically asking, hey, are you secure? And by the way, here are all the secure languages I know how to speak. The server then replies with its own hello, and crucially, it presents its ID card, and that's its digital certificate. Now, this digital certificate is super important because it does two key things. First, it holds the website's public key, which is a critical piece of the encryption puzzle. And second, it acts like a digital passport, proving the website is legit. But, who issues this passport?
Well, that's the job of a certificate authority, or a CA. These are globally trusted organizations, kind of like a digital passport office, that verify a website's identity before they'll issue a certificate. And your browser already has a list of these trusted authorities built right in.
Okay, so your browser does a quick background check. It looks at the certificate and confirms it was signed by a CA that it already trusts. Once that checks out, your browser uses the website's public key to create and send back a secret message. From that one message, both your browser and the server can generate an identical, brand new secret key that's only good for this one conversation. That is the session key.
And with that handshake complete, the real magic starts. From this point on, every single piece of data, every click you make, every form you fill out, every password you type is completely scrambled using that unique session key. So even if someone managed to intercept it, it would just look like unreadable gibberish.
Now, this whole system works because we can trust that the website we're talking to is the real deal and not an imposter. And that guarantee comes from a concept that is the absolute bedrock of online security, the chain of trust.
This is a really important question, right? What's to stop a scammer from just creating a fake certificate for, let's say, your bank's website? Well, the answer is in the clever way that trust is actually structured and verified.
You see, trust isn't just based on that one certificate. It's a verifiable chain. It starts with a root CA, which is already installed and trusted by your browser from the get-go. That root might then authorize an intermediate CA, which then issues the final certificate to the actual website. Each link has to vouch for the next. It's a distributed web of verification, and it's what allows billions of devices to connect securely.
And this is why you sometimes see that big, scary warning page. If your browser can't verify the certificate all the way back to a trusted root, maybe the certificate is expired or it's from a source it doesn't recognize, it immediately throws up that connection is not private warning. That's your browser screaming, hold on, I can't vouch for this site's identity.
So we've gone deep into the how of it all, but let's just take a moment to focus on the why. Why is this whole architecture so absolutely critical for the web we use every day? Well, it really boils down to three fundamental protections. First, privacy. That's the encryption keeping your data secret. Second, integrity, which makes sure the data you get hasn't been secretly changed along the way. And third, authenticity, confirming you are in fact sending your password to your actual bank and not some imposter. Because these protections are so important, HTTPS isn't really optional anymore. It's the standard. Modern browsers will actively warn you to stay away from unsecure sites, and search engines like Google even give a small ranking boost to websites that use it. It's all about making the entire web safer for all of us.
So when you really look at it, HTTPS isn't just one thing. It's this complex, interconnected system. It's an entire ecosystem of certificates, public and private keys, trusted authorities, and powerful encryption, all working together in perfect harmony every single time you connect.
So the next time you see that little padlock, remember everything that's happening behind the scenes. It's not just an icon. It's the visible tip of the iceberg, a sign of a deep, robust, and brilliant architecture of trust, quietly protecting your digital life one handshake at a time.